Welcome to the deep dive. Today, we're diving headfirst into a topic that touches almost every facet of our modern world: data analytics. In a world swimming in this ocean of information, making sense of it all can feel like trying to drink from a fire hose, probably getting soaked in the process. But what if there's a way to not just drink, but to extract the purest, most potent insights? That's what we're here to uncover.
Exactly. This deep dive is designed to show you precisely how organizations are transforming that raw, often overwhelming volume of data into valuable, actionable insights for decision-making. We're going to try and cut through the noise and get straight to the most important nuggets of knowledge quickly so you can understand what's truly happening behind the scenes.
Okay, let's unpack this then. Before we get too far, we need to understand the foundation. What is big data anyway? When we talk about it, we often hear about the 3 V's: volume, variety, and velocity. And these aren't just buzzwords, are they? They illustrate a profound shift. I mean, imagine trying to make sense of Facebook generating 4 petabytes of data every single day. That's the sheer volume we're dealing with.
Okay.
Or think about the mind-boggling variety, from tweets to MRI scans, all needing to be crunched at incredible velocity, sometimes in milliseconds. This isn't just about more data, it's about a whole new scale that enables insights previously impossible.
And that's precisely where data analytics comes in. It's the essential process of collecting and examining all that data to extract meaningful business insights. These insights are then used to inform decision-making and ultimately improve performance. This isn't just guesswork. It's done through rigorous methods like statistical analysis, the regression, which helps us see how one factor might predict another. And increasingly, machine learning, where computers learn from data without explicit programming. While powerful software like Tableau, Microsoft Power BI, or ClickSense handles the complex analysis and modeling, it's crucial to remember that human interpretation is key. We still need to assess if the patterns and trends identified by the software seem realistic or, plausible.
So understanding these fundamentals is a real shortcut for you to be well-informed about how businesses operate in this digital age. It's not just for data scientists anymore, it's for everyone. As we've been looking through the sources, a pattern starts to emerge for how data tells a story. I've been thinking of it like the 3 pillars of analytics. First, what happened, then why did it happen, and finally, what will happen.
That's a great way to frame it. The first pillar is descriptive analytics. This is about using current and historical data to identify trends and relationships, essentially telling us what has happened. Yeah. It's quite accessible, actually. Even basic software like Microsoft Excel can be used for this, allowing you to create simple visualizations like line graphs, bar charts, or pie charts to highlight trends.
What's really fascinating here is how companies use this. Think about Netflix.
Mm-hmm.
They gather an incredible amount of data on users' behavior, what shows you're watching, what types of programs you prefer. This allows them to analyze the data and determine what TV shows and movies are currently trending. They then share these trends with users to give suggestions. But it's not just about what to watch next, is it? This knowledge profoundly shapes their decision-making on future programs to commission. They know what themes or actors are popular and can use that to refine their content strategy or even retarget campaigns to recommend more shows to you.
Absolutely. And once an organization understands what happened through descriptive analytics, the natural next step is to understand why. This leads us to diagnostic analytics. This type of analysis aims to determine the causes of trends. Understanding why a trend is developing or why a problem occurred is critical for making effective decisions. Often there's more than one contributing factor, and diagnostic analytics helps organizations understand the range of internal and external factors that affect outcomes and which ones have the greatest impact. Techniques here often involve statistical software tools, including data drilling.
Data drilling, what's that exactly?
Well, it means delving deeper into summary information to reveal more detail. For instance, a consolidated sales report might show an overall increase, but drilling down could reveal that sales of some products are soaring while others are plummeting. Or you could look at regional sales or channel sales, that sort of thing.
We saw this in a fascinating example with staff turnover. A company noticed one department was hiring significantly more people than any other, but there was no net increase in headcount because their staff turnover was also much higher.
Right.
By drilling down into the data, they discovered that many of these positions were for a specific team, and that team paid its staff less than the industry average. Identifying that root cause allowed the company to review pay scales and implement other retention measures.
That's a perfect illustration. Another great example of diagnostic analytics in action is HelloFresh.
No.
Their business model relies on selling and delivering prepackaged meal boxes. For them, understanding customer preferences, what recipes, ingredients, or meal times each household favors is crucial. By collecting data on customer preferences and even the reasons for subscription cancellations, HelloFresh has developed algorithms to forecast demand more effectively, reducing food waste and optimizing product selections.
So if they know you always eat fish on Fridays.
Exactly. They can target tailored seafood offers. And understanding why people cancel helps them improve their product and user experience, boosting customer retention, and increasing profit margins. But it's not just about the numbers. It also involves thinking laterally, considering external factors. For example, a sudden surge in sales for a clothing brand might be traced back to a celebrity wearing one of their products. However, it's important to add a note of caution here. Diagnostic analytics relies on past data, which may not always predict the future. And critically, correlation does not necessarily imply causality. Just because two things happen together doesn't mean one causes the other.
That really highlights that correlation isn't causation, which means simply looking at numbers isn't enough, does it? You need that critical human element.
Precisely.
It makes me think of the classic example of ice cream sales and shark attacks.
Ah, yes.
If you look at monthly data for both, they're highly correlated, both increase in the summer and fall in the winter. But that doesn't mean eating ice cream causes shark attacks.
Right. It's the third factor.
Rather, people consume more ice cream when it's warmer, and they also swim more in the ocean when it's warmer. Warm weather causes both. It really underscores the need for careful analysis.
Indeed. So once you understand what happened and why it happened, you're ready for the third pillar. Predictive analytics. This is the process of using data, historical information, statistics, computer modeling, and machine learning to forecast future trends and events, including the probability of various outcomes. While it still uses historical data, its purpose is entirely forward-looking.
Take a mobile phone provider, for example, that experienced an increase in customer churn. Diagnostic analytics might have revealed that their promotional deals simply weren't incentivizing renewals. Predictive analytics could then step in to forecast the impact of different combinations of upfront costs and monthly fees to see which would be more attractive and lead to more renewals.
Exactly. In retail, predictive analytics helps with incredibly accurate demand forecasts. They use historical sales data, market trends, demographic data, even browsing patterns to inform inventory management, staffing decisions, advertising campaigns. One of its most valuable forms is what-if analysis.
What if?
Yeah, where you change variables, say economic growth or new competitors entering the market or launching a new product to understand how those changes might affect sales forecasts.
A great real-world illustration of this is dynamic pricing in hotels.
Okay.
Revenue management aims to have the right room for the right person at the right time. They use analytics and customer data like historical and current reservations, occupancy rates, daily rates, and external factors like weather, local events, even competitor pricing to predict demand. This allows them to automatically adjust room rates, increasing them when demand is high, and reducing them during quieter periods to boost occupancy.
It's very effective. But just like diagnostic analytics, a word of caution is still necessary. While predictive analytics is forward-looking, it fundamentally relies on past data, which, as we know, isn't always indicative of future results.
Right, the past doesn't perfectly predict the future. So far, we've mostly talked about numerical data, the kind you can easily put into a spreadsheet. But remember the variety aspect of big data.
Yes.
Analytics isn't just about numbers. It increasingly includes unstructured data like text, images, video, and even voice. These new methods of data analytics are unlocking incredible insights.
First up, text analytics. This involves translating large volumes of text like emails, social media posts, or customer support tickets into quantitative data to uncover trends and insights. By tagging responses based on keywords and their tone, text analytics can identify main topics, issues being discussed in product reviews, or people's attitudes to a brand. A key technique within this is sentiment analysis.
Sentiment analysis.
Which uses natural language processing, essentially teaching computers to understand human language to determine if a piece of text is positive, negative, or neutral. It tracks the tone, intent, and emotion behind messages.
So if a bank customer complains, I needed to go into the bank branch today. There was a long queue, but there were only 2 cashiers working, so it took forever to get served. The analytics software would identify took forever as negative sentiment.
Exactly.
That's a powerful insight for the bank, signaling a need to monitor cashier numbers more closely.
Exactly. Or consider Call High, a smartphone retailer, which used text analytics to analyze customer comments on social media after a fall in revenue. Posts like battery life and the new call height is very poor were tagged as product performance and negative. But posts saying the advisor I spoke to was well-informed and helpful were tagged as customer support and positive. This analysis showed that poor product performance was a key factor in falling revenue, leading them to prioritize improving things like battery life. On the flip side, their strong customer service was helping to retain customers, so they knew to maintain those high standards.
The benefits here are clear. Improved customer satisfaction by understanding likes and dislikes, quickly detecting product or service issues, and constant monitoring of brand reputation.
Absolutely. Next, we have image and video analytics. Image analytics is essentially a computer's ability to recognize elements in pictures, whether they're physical features, objects, or movement. Video analytics applies similar principles to a series of images or actual videos. The ability for computers to interpret these visual sources has significant business implications.
This is truly game-changing for retailers, isn't it?
Yeah.
Traditionally, they relied on point-of-sale data, which tells you what was bought.
Right, only the final transaction.
But video analytics offers so much more. How long customers spend in different store sections, which areas are most visited, what proportion of visitors leave without a purchase, or even what products customers look at but don't buy. Retailers can use these insights to, say, introduce deals on products that are frequently browsed but not purchased, converting interest into sales.
Precisely. And it's not just retail. Hospitals can use video analytics to monitor patient rooms, tracking nursing staff visits, and alerting teams if a patient hasn't been checked on within a certain time frame.
Wow. Okay.
Finally, let's distinguish between voice analytics and speech analytics. This is an important difference.
Okay.
Speech analytics focuses purely on what was said, transcribing words, identifying keywords like late deliveries in contact center calls. This can help monitor performance or provide real-time assistance to agents. Voice analytics, however, goes deeper. It focuses not just on what was said, but also on how it was said.
The tone.
Exactly. It analyzes patterns in tone of voice, volume, pitch, and speed, revealing the emotions within the conversation.
This is so important. Imagine a customer says, "Great, so now I won't be able to do anything until next week," in response to a delayed order. Speech analytics would only register the word "great," which normally implies positive sentiment.
Right. It misses the context.
But voice analytics would detect the sarcasm and the true negative emotion, giving a far more accurate picture of the customer's mood.
Precisely. Voice analytics greatly improves the customer experience because it provides that deeper emotional context. It can even trigger real-time alerts for supervisors if a customer is becoming angry or if an agent is struggling, allowing them to intervene immediately.
As powerful and versatile as data analytics is, there's a crucial frontier we need to discuss: ethics.
Yes, absolutely critical.
While capturing and processing personal data offers incredible insights, it also raises significant ethical and privacy issues.
This brings us to data ethics, the moral obligations of gathering, protecting, and using personally identifiable information. There are several key issues to consider. First, ownership. Individuals own their data. Organizations need consent to collect it, which is why you see privacy policies and cookie checkboxes everywhere.
We all just click accept, mostly?
Well, yes, but the principle is there. Second, transparency. Individuals have a right to know how their data is being collected, stored, and used. If a company personalizes your website experience, they should explain how cookies track behavior and how that data is used. Third, privacy. Even with consent, organizations have a responsibility to secure personal information through secure databases and encryption.
That seems obvious, but breaches happen.
They do. Fourth, intention. Before collecting data, an organization must question why they need it, what they'll gain, and what changes they'll make. This brings up an inherent conundrum in big data. We're gathering more data than ever, but ethically, we should strive to collect only the minimum viable amount necessary.
That's a tough balance.
It is. And finally, outcomes.
Yeah.
Even with good intentions, data analysis can inadvertently cause harm to individuals or groups.
This last point about outcomes really spotlights the issue of algorithms, doesn't it?
It certainly does.
Algorithms are sets of instructions written by humans for computers to solve problems or complete tasks. And because they're written by humans, they are inherently subject to human bias, whether intentional or unintentional.
That's right. Bias can creep into algorithms in two main ways. First, through training data. Machine learning algorithms learn from the data they're fed. If this data set is unrepresentative, the algorithm can learn to favor certain outcomes over others. Organizations must ensure their training data is properly representative.
So garbage in, garbage out, basically, but with bias backed in.
Kind of, yes. Second, through feedback. Algorithms also learn from user feedback, which can itself be biased. For example, if a job search platform's algorithm recommends roles and hiring managers consistently select candidates from one demographic group, the algorithm will learn to only provide job listings to that group in the future, reinforcing the existing bias.
Wow, okay.
This can be especially problematic with black box algorithms,
Black box.
where the inputs and operations are visible, making errors or biases hard to detect until the problems become severe. You don't know why it's making the decisions it is.
This brings us to a compelling and often debated example from the sources, predpol, or predictive policing. This is an AI algorithm used by police departments in the USA, intended to predict where crimes will occur. The idea was to reduce human bias in policing. However, researchers found that predpol itself became biased. It repeatedly sent police officers to specific neighborhoods with large minority populations, regardless of the actual crime levels compared to other areas.
How did that happen?
Well, it seems to have happened because biased arrest data, where police historically make more arrests in minority neighborhoods due to higher police concentration, not necessarily higher crime rates, was fed into the algorithm.
The training data issue again.
Exactly. This created a self-reinforcing cycle where predpol directed more police to those areas, leading to more arrests and further solidifying the algorithm's bias. Now, we bring this up not to endorse any specific viewpoint, but to clearly convey the ideas and findings from the source material about how even well-intentioned algorithms can perpetuate existing biases.
That's a really important clarification. It's about understanding the potential pitfalls.
So understanding these ethical implications is crucial for you, whether you're a consumer whose data is being collected, an employee impacted by data-driven decisions, or simply someone living in a world increasingly shaped by these powerful systems. So there you have it, a deep dive into data analytics. From understanding what has happened to diagnosing why, to predicting what will happen and leveraging insights from text, images, and even the nuances of voice. The power and versatility of data analytics are undeniable.
They really are.
But with that power comes a profound responsibility to use it wisely and ethically.
Absolutely. And that leads to a provocative thought for you, the listener, to consider. Given the immense power of data analytics and the algorithms that drive it, what steps do you think organizations and even us as individuals should take to ensure that data is not just useful, but also used justly and equitably?
A great question to ponder. Thank you for joining us on this deep dive. We encourage you to continue exploring and critically examining the data that shapes your world.